Okay, sorry I got cut off there a little abruptly in the last video. Wanted to do one more example here, Bayes' theorem. All right, man is known to speak lies 1 out of 4 times. He throws a die and reports that it's a 6. Find the probability it's actually a 6. So we want the probability that a 6 is actually rolled given that it was reported as a 6. So we're going to let E1 indicate getting the 6. E2 is the complement, not getting a 6. And we're going to say that E is the reporting. E is the reporting of a 6. So you want to be careful here. There's actually what happened and what was reported. The probability of E1 getting a 6 is 1 out of 6. That's the same thing as getting a 5 or getting a 2. And rolling a die, they're all equally likely 1/6. The probability of not getting a 6 is the complementary event, 1 minus 1/6, or 5 out of 6. So the probability of E given E1 is probability that a 6 is reported given that the 6 actually occurred. Now, under that circumstance, that would be telling it the truth that a 6 was rolled and it was reported. Now, the probability of E given E2 would mean that a 6 was reported when the actual roll was not a 6. So that would be a lie, which is 1 out of 4. The probability of lying is 1 out of 4. The probability of telling the truth is the opposite, 3/4. Yeah, I suppose have that from the opposite point of view. It's still correct, but we were told that that lying 1/4 of the time. So the probability of telling the truth is 1 minus 1/4, which is 3/4, and the probability of lying is given as 1/4. We want the probability of getting a 6 given the man reports it to be a 6. So that's E1 given E. We reverse that around, E given E1. E given E1 is just speaking the truth, which we know is 3/4. And then the probability of E1 is getting a 6, which is 1 out of 6. And then downstairs, notice it's the same term in the front, 3/4 times 1/6. Then the second part is the probability of reporting a 6 given it's not a 6, which is a lie, and that's 1/4 of the time, times the probability of E2, which is not getting a 6, which is 5/6. We have a common denominator of 24 here. Numerator is 3/24. Denominator is 3 plus 5, so it's 8/24. 24s cancel out, and the probability is 3/8. All right, we're going to stop here. Going to have some information coming up soon on the project, which is the first project, which is group work on applications with Bayes' theorem. Again, if there's any questions, please don't hesitate to reach out. Thank you.